Hey guys, welcome back to another video. Today we're doing another UKMT question. So this is the question. A Saxon silver penny from the reign of Ethelbert II in the 8th century was sold in 2014 for £78,000. A design on the coin depicts a circle surrounded by 4 equal arcs, each a quarter of a circle, as shown. The width of the design is 2 centimetres. What is the radius of the small circle in centimetres? So to make it easier for us, we'll draw the diagram again, adding our quarter of a circle that they've mentioned. So we have our 4 equal arcs. With our circle in the middle. And then when it means a quarter of a circle, you draw a line that is perpendicular to the points here, like that. And then create right angle triangles. And then right angle triangle there too. And then, so we know that the width of our design is 2. So we have 2, 2, and 2. So really we've made ourselves right angle triangles which have hypotenuses of 2. The reason why they are right angle triangles, it is because each segment is a quarter of a circle and a whole circle is 360 degrees, so a quarter of that is 90. Okay, so we have our hypotenuses which are 2. And then we can use Pythagoras' theorem to find out the lengths of our 2 sides, which are here. So if we have 2 here, and then we have, each side is x. So the reason why x's are the same is because the x is the radius of the circle. So wherever you draw the radius from the centre is always going to be x. So you have x and x there. So yeah, so so we have x, so 2x squared, because then you have x squared plus x squared, which is 2x squared, equals 2 squared. So then, simplifying the equation, you then get x squared equals 2, because 2 squared is 4, 4 divided by 2 is 2. And then x equals root 2. So now we know the radius of the circle is root 2. So you can write that there. So root 2, root 2, root 2, and root 2. And then we've got that. So now we can draw a line that runs diagonally across the square, and then what we will know is that this would be the lines that we will say this is from A to B. So the line AB is a hypotenuse of this triangle here, and then if we find out the length of AB, we can subtract both radiuses of our segments and then get the radius of our circle, because the radius of our segments also includes this part here that is originally used in the diagram. So yeah, okay, so finally what it is that if we find the hypotenuse, which is AB, and that's a hypotenuse of our red triangle here, we can subtract both radiuses from the centre of A outwards there and from the centre of B outwards here, and then you'd get the diameter of the circle in the middle, and then half that to get the radius. So if we draw the red triangle again, we basically have our base, which we know is the 2. We know our base is basically 2 lots of 2 root 2. So that would be 2 root 2. And then our height would be the same as well. So 2 root 2. And then c squared basically here. So 2 root 2 squared plus 2 root 2 squared equals c squared. So if we do each individually, 2 squared is 4, and root 2 squared is 2. So 4 times 2 is 8. So 8 plus 8, which equals 16, which equals c squared. So if 16 equals c squared, then c equals root of 16, which is 4. So c is 4. So our AB basically equals 4. So from there and there. So if that's 4, and then we have our radiuses, which we know are root 2. So from B to the outer circumference and from A to the outer circumference, then we can just do 4 minus 2 lots of root 2. 4 minus 2 lots of root 2, which would be the diameter of our circle. Then if that is the diameter of our circle, then the radius would just be half of all of that. So it should be 2 minus root 2. And that's it. That's the answer. Thank you guys for watching our video. Please make sure to like, comment, subscribe, and we'll see you next time. Bye.